Hi folks, welcome to this video on trickier log equations. In the last video we sort of split them up into ones where you could make it a quote short log equation, or one where you'd change to exponential form, or one where you'd put a single log on each side. So if I'm looking at this first one, they're all natural logarithms. So that looks like it's going to be one where we make single logs on each side. So I'll use my log laws to put this first one together. I have subtraction of logs, therefore it's a single log, natural log, with division. The problem with this side is this -1, and this is one of the sneaky things. So you can't just say equals negative ln x and then drop the logs. That's not going to be equivalent. What you can do, however, is interpret that negative ln x. Negative means -1 times ln x. And so where could that -1 live? It could live up as an exponent here. I can write it like this, x to the -1. And I'm going to show you an alternate way to do this one in a minute, but I think this is probably the one that would spring to mind first if we're just sort of following our mechanics. Okay, so that means ln of x plus 2 over 3 equals ln of x to the -1 is just 1 over x. This is the stage where we can drop our logs because we have a single log on each side. If the ln of x plus 2 over 3 is equal to the ln of 1 over x, then x plus 2 over 3 must equal 1 over x. So I'm going to drop my logs. I'll make sure that I solve in the end. Now, here you've got a equation that has some fractions in it, which is kind of annoying, but we can get rid of them. If you feel comfortable, you can get rid of everything at once. You can do cross multiplication if you like. I'm just going to times each side by 3. And that'll get rid of this 3 here for me. And then I'll have x plus 2 on the left equals 3 over x. And I still have a fraction. And so I'm going to times both sides by x. And this will give you the same result as if you did, say, cross multiplication, or if you multiply by 3x at the start. But I think maybe it's a little clearer here. If we dealt with one fraction, then we dealt with another. See, these x's would cross out. Oh my gosh, it's a quadratic. This is so exciting. We're going to make one side 0. Mercifully, it's a short trinomial, so we'll factor it. Things that add to 2 and multiply to -3 are plus 3 and -1. Okay, so that's going to give us an answer of -3 and +1. Let's go check the original equation. Can I put a -3 in here or in here? No, that'll give us ln of a negative. You can't take the log of a negative, so that's not a solution. The 1, though, will be fine. You can go ahead and check that will actually give you something balanced, but the main thing is that it's not going to break the law by putting in a 1 here or a 1 here. So there's a solution. So the trickiness here was that negative in front of the ln x. An alternate way you could approach that, if you find that not pleasant having these negatives, you don't have to have negatives in equations. You can move stuff around until it's all positive. So we could move this ln 3 over to this side and move this ln x over to this side. Let's see, what would that look like? Ln x plus 2. So to move the ln 3 over, I'll have to add ln 3 to both sides. And to move this ln x over, I'll have to add ln x to both sides. So let me make a little more room so we can see what this looks like rearranged. Ln x plus 2 plus ln x equals ln 3. There we go. No more subtraction, which is kind of nice. But the really nice thing is that it will mean that there's no division or no fractions involved if we do it this way. So ln x plus 2 plus ln x, that means you just multiply to make a single log. We could not drop the logs at this stage here, okay, because we don't have a single log yet. And now when we drop the log, we get something pretty pleasant. Instead of having the fractional stuff that we had to deal with, we just end up with the quadratic sort of simply expressed, and we can go ahead and solve, and we can go ahead and check, and we'll find that once again -3 does not work, but 1 does. The IB will often give you a domain for your solutions anyway, so they'll say like x is greater than 0. So you'll know that you'd have to cross out the x equals minus 3. All right, one other tricky log one. The trickiness here is that we have different bases. Okay. So when we have different bases, we need to convert to a common base before we can exploit any of our log laws. And if we want to change base, we need to use the change of base rule. I'm going to head to the formula booklet. Okay, so here I am, Mathematics, Analysis, and Approaches formula booklet. And I scroll through prior learning. This is under number and algebra. And here's all our exponents and logarithm stuff. And if you see, the very last thing that's written here is log a of x equals log base b of x over log base b of a. In other words, you can take the log of the big number over the log of the little base. Now, I don't love the way that they present it in the formula booklet. I've written it here. I always think of it this way. Log base a of something is log base c of that big number over log base c of the little number. Just because it can get confusing because your equation already contains x's. But the big idea here is if I wanted to change this one here, the log base 4 of x squared, into a log base 2, I would just write it as log base 2 of x squared over log base 2 of 4. And then I'd have the other one that says log base 2 of x minus 2. X minus 2. I wrote one thing and said another. Equals 3. Okay. In the end, this is going to be one where we transfer to exponential form at the end. But we don't have to quite yet. Or you could use another approach if you really want to. This whole thing of finding a common base for your logs, though, is really important. This looks like a mess at this stage, but just think about this statement here. Log base 2 of 4 is asking you, 2 to the what makes 4? Like, what's the missing exponent? Oh my gosh, the log base 2 of 4 is just 2. Okay. And then we have plus log base 2 of x minus 2 equals 3. I still can't quite combine them. I'm going to do something that my log laws will let me do here. I'm going to bring down this 2 so that they can divide out. But alternately, you could have called it a half and brought it inside. So I'll just use my log law of powers. 2 log base 2 of x over 2 plus log base 2 of x minus 2 equals 3. Now we can cross out these 2's. Okay, and we'll keep working that way. We have log base 2 of x now, plus log base 2 of x minus 2 equals 3. And from there, we can use our log laws to combine those first two on the left. So we'd use multiplication because there's addition between logs. So we get log base 2 of x squared minus 2x equals 3. And at this moment, you might be saying, oh my gosh, it's going to turn into the same quadratic as the last one. And that's a common error that people will at this point just drop the log on one side. But the golden rule of equations is that you have to do the same thing to each side of the equation. So that's really not an option here. If we wanted to do that, we'd have to re-express 3 as log base 2 of something. That something would be 8, and it wouldn't be a big deal. But what I'd be thinking at this point is this is one where we use bay or switch forms. Okay, so I have to get out of a log. I do that by converting to exponential form. 2 to the 3 equals x squared minus 2x. Change to exponential form. Okay, and we can continue on with this. That means we have 8 equals x squared minus 2x. Oh my gosh, another quadratic. This is so exciting. And and we'd make one side 0, we'd factor it, look for magic numbers that add to -2 and multiply to -8. Those would be -4 and +2. And so we'd get x equals 4 and x equals -2. Those are our answers, as long as they both work. Let me see, can I put 4 into here? Yep. Can I put 4 into here? Yeah, it'll give me log base 2 of 4 minus 2, which is 2. So 4 is an answer. Can I put -2 into this one? Yeah, I can, because of the way the question's originally presented with a square. Can I put -2 in here? No, that would give me the log base 2 of -2 minus 2, or log base 2 of -4. Can't take the log of a negative. So there are a few sort of trickier ones. These logarithmic equations don't come up a whole lot on IB exams, but they have been known to. They're annoyingly not in your Oxford text, but it's a thing that you should know how to do, at least the basic ones, and then here are a few trickier ones. So there are practice questions in the video description. There aren't a whole ton of them, but you can try your hand at a few of them. And there are also practice questions like this on Revision Village. I hope this has been helpful. Take care, folks.